Thank you, everybody. And welcome, good evening, good morning, whatever time it is for you. I'm Manny Silva, and today we're going to explore how self-healing documentation systems are already changing the way that we maintain API documentation, developer portals overall. Imagine documentation systems that automatically detect and fix their own issues, staying accurate and reliable even as your products rapidly evolve. Now, I'm head of documentation at Skyflow. I am also the creator of and maintainer of Doc Detective. I'll be touching on a whole bunch of other stuff that I've done throughout the presentation, so I'm not going to go into it all that much right now. But we're going to start by reviewing the current state of Docs pipelines, dive into suites of tools that power self-healing Docs systems, and explore how these new tools integrate with existing ones. So first, let's take a look at the typical components of a Docs pipeline. These include authoring tools for content creation, publishing tools for rendering, and collaboration platforms for team coordination. In a traditional content management system, CMS or CCMS, you often rely on WYSIWYG editors for content creation, with publishing tools generating outputs like PDFs and HTML files. Collaboration is typically managed through platforms like SharePoint or Jira, and this all might be managed in a big monolithic system like Adobe Experience Manager. And in your typical CMS pipeline, where documentation requests are managed in Jira, in this particular hypothetical, content might be authored in Madcap Flare, and outputs could be published to SharePoint or to a web server. Now, let's take a look at the equivalent in a Docs as code pipeline. These tools would include version control systems like Git, text editors like your IDEs for content text editors or IDEs for content creation, static site generators for rendering, and CI/CD pipelines for automated builds and deployments, and you've still got your collaboration platforms for team coordination. So if you happen to be GitHub focused, this example here shows how you might have documentation requests managed in GitHub issues. Content being authored in VS Code, versioned in GitHub, built and deployed via GitHub Actions with Docusaurus as the static site generator, and published via GitHub Pages to actually host the documentation. While the current pipeline offers many benefits, it also presents many significant challenges. Content creation is largely manual, though there are exceptions like references created from OpenAPI definitions, as have been discussed today. But those definitions still need to be manually crafted. Even if they are generated from your code, you still have to write the words that appear in the OpenAPI definition somewhere, whether that's in an overlay or directly in the code, or if you are like me and you hand write your OpenAPI definitions right there. Content testing can be really, really time consuming if it happens at all. When was the last time you did an actual freshness check on your documentation? And maintenance overhead can be really significant, especially for large documentation sets, where a broken concept can cascade into broken references and inaccurate guides and tutorials. We've got a maintenance nightmare. If you maintain API documentation, developer portals, you know the pain. A single API change can cascade through dozens of code examples. API examples, product releases happen weekly or daily, but documentation updates can lag behind, and the result is frustrated developers and damaged trust. What we see here is an optimistic timeline. In reality, broken documentation often goes unnoticed for weeks or months, especially if it's hidden really, really deep in your references. And by the time that it's fixed, internal and external developers have already lost confidence in your documentation. Because if it wasn't accurate in the first place, why should it be accurate again in the future? And if it's not accurate now, well, what can you possibly do to regain the trust when your customer has already started looking at alternatives? But what if your documentation could detect these issues automatically? And what if your documentation system could propose fixes and create pull requests and even update itself while you sleep? It's happening today. Self-healing documentation uses agentic AI systems that can perceive their environment, your docs and your products, reason about issues, and take corrective actions. And yes, I understand that it's not real reasoning, but that's the term, so please bear with me. Think of the self-healing documentation systems as intelligent assistants that never sleep. They exist today. They're very new, but they're here. Let's talk about the pieces of the stack that make it work. There are a few categories of tools that make up this stack, and they can independently and individually help automate routine tasks and accelerate dynamic ones, but when knit together, they're incredibly powerful. So first, this is the one that most of us are familiar with: content generation tools, what most people think of as typical LLMs. They help tech writers, content creators of all stripes quickly create initial drafts or supplementary content. They can take inputs like documentation requests, planning documents, API specifications, whatever, and generate comprehensive drafts, and freeing us, the writers, to focus on refining and enhancing the output. But no, I'm not talking about ChatGPT. I'm not talking about Claude. I'm talking about AI specifically applied for the purpose of generating novel technical content that takes into consideration the constraints of technical content. And content generation tools can take various inputs, like we already talked about. So if I have a planning requirements document or anything else to supplement whatever that defines what the new feature that I'm trying to document does, what it's supposed to do, how it's going to work, I pass that into my tool that can help me generate the documentation. I review it, I tell it to go back and revise things as necessary, and then eventually I get to a final draft, not necessarily final documentation. So if you're tasked with documenting a new feature, you could pass in all of your source contexts and ask it to generate a conceptual overview, a how-to guide, code samples based on all of the information that you've provided. And in this case, the writer's role shifts from refining and enhancing to leveraging my expertise for higher value tasks. And I know this works because I built one. VerbaGPT is an internal tool that generates first drafts based on known good uploaded content. It is internal to Skyflow. I wrote about the initial version on the Amazon Machine Learning blog. I've revised it since then, but it takes templates that define best practices for how we use it in these doc types in Skyflow. And it's reduced my time to first draft from, I don't know, a day to 5 minutes. It's a huge time saver. We've been using it for over a year, and it also lowers the barrier of entry for folks throughout the company to contribute to the documentation, not just the docs team. But doing this isn't easy. It has to be accurate. The system needs to be able to get the right segments of content at right time, which means RAG, which is hard enough. Every step of this is hard. There's a reason I haven't tried to productionize VerbaGPT outside of Skyflow. But there are other people who have done it. We've got Oxygen AI's Positron, Document 360, Hereto. There's docs.dev. GitHub Copilot can be really good for this. And there's also Cursor. Now, I know I'm going fast. I have a lot of slides to cover. Forgive me. But all of these tools can significantly speed up the writing process. Now, group number 2, linters. Linters have been around for a long while, but they are as indispensable as ever. And they make sure that our content is structured correctly and that we conform to company style guidelines, that we're not breaking any formatting rules that would break our tooling. Well, there we go. I was able to get up here and show all of this, but one of my slides decided not to behave. You can see most of the diagram here, but using a linter is pretty straightforward. You pass your content to a linter, which outputs the results, and the hardest part is configuring your rules. Where things get interesting is when the linter results get interactive. And you can do this today with IDE integrations like in VS Code, where if you have a linter setup like Veil, you can get your linter results directly in line. You can also output it to other tools, which is where it comes in handy later. And I know this works because I use them. I already mentioned Veil for prose linting and style guide adherence, but there's also Markdown lint if you use Markdown as your content to make sure that you're using the syntax correctly. We've got Redockly and Spectral and, for OpenAPI definition, async API definition, Arazzo linting, and I did also build a prototype of a documentation structure linter. So all of this can inform whether or not we're doing this accurately, that we are conforming to style and our semantics. Now, the next set of tooling is content testing. Content testing tools embody the docs as tests philosophy and strategy. They treat documentation like code in that they apply automated testing principles to ensure that the content, the procedures, the code examples are accurate, that they're reliable. They actually perform the tasks to make sure that they can be performed as written. And this approach significantly reduces the risk of outdated or incorrect information reaching users. I can talk about this for hours. I literally wrote a book on the subject. But know that there are already tools that verify the syntax of the markup and the prose, the linters I just talked about. They are incredibly important, but this literally verifies the intent of the procedures, the accuracy of your procedures. And content testing tools can integrate into CI/CD pipelines, automatically checking documentation content for accuracy. So you know your documentation is up to date, because if the procedure can't run against your product, whether it's a UI, whether it's an API, whether it's CLI process or SDK code examples, the testing tool will let you know. And you don't have to run this in CI/CD. You can also trigger these validations manually while you're drafting content, or you can run these on a schedule to ensure freshness. Instead of doing freshness checks every year, you can do freshness checks every day for your entire doc set, or once per release, or once per push into a staging environment. There are many, many possibilities about when and how you might run these tools. So let's say you have a UI-based procedure, and a content testing tool like Doc Detective can open a web browser and navigate through the steps of the procedure in the UI. If you have an API-based procedure, it can make calls and check the responses to make sure that not only is it what you expected, but both that the requests and responses conform to the schemas defined in your API definitions. If you have a CLI-based procedure, it can run the commands and check the outputs, including checking it against what the output was the last time you ran it to find regressions. If these tools can catch errors that would otherwise slip through the cracks, and they can do other things like check for screenshots, automatically capture screenshots, and do visual regression testing to see if the UI has changed out from under you and if your screenshots are out of date. And guess what? They can save the new ones for you so you don't have to do it manually. These tools let you catch the issues before they reach production, before a user ever runs into them. And I know that these work because I built one of these tools. Doc Detective it automates documentation testing. It does everything that we just discussed so that you can be confident in your documentation, so that you can know that it is reliable, so that you can build and maintain trust with internal and external users instead of turning them away. Content testing tools are powerful, but they're not without their challenges. They require a deep understanding of the product interfaces that you're trying to test against, and those interfaces need to be able to be accessed programmatically. And while this is doable, after all, your engineering teams, your QA teams are doing this with their testing tools, there's certainly a learning curve to it today because this isn't a skill that most tech writers have. And there are a surprising number of tools that can help you do this today. Obviously, there's Doc Detective, as I mentioned before, but Azure has Innovation Engine that they released last year that can do bash command checking in README files. There are Jupyter notebooks that are inherently testable by their very nature because they're a style of run books. RunMe is a tool that makes Markdown into runbooks. And then there's the Erato specification that helps define API-based workflows. Now, I've talked about a whole bunch of tools. Let's finally get to the self-healing. Content self-healing tools, in my eyes, represent one of the cutting edges of documentation automation. They promise to handle routine tasks automatically, allowing us to focus on the more complex, the higher level, the more creative aspects of our documentation. And as expected, these are going to be agentic systems. Now, way earlier, I mentioned that they had access to their environments. In this case, their environment is our documentation and all of the systems that the AI agent has access to. The validation checks, the linters, all of that. And agents are actively being developed today. So for an example self-healing flow, you might have a validation tool like Doc Detective or RunMe or a Jupyter Notebook that runs its tests and detects an issue. And then it reports an issue to the healing agent. The healing agent is able to go and investigate the docs. It's able to go and research issues in your collaboration platform or look at system logs, look at your Git history so that it can identify when a UI string changed, who changed it, why they changed it based on the commit history. And then they can go and try to identify a fix, whether the fix is in the docs, in which case they might try to draft a fix and spin up a PR that you would just have to review and accept. Or if the fix is in the product, maybe it's a bug that somebody introduced, they might send a message to contact the appropriate teams. But it's not just validation tools that kick off this process. There are some tools that can monitor PR changes or code changes in your engineering repositories and then analyze your documentation to see if there are gaps and be able to suggest changes based on the introduction of a new enum or a new entity or resource in your APIs. So imagine a scenario where a change monitoring tool detects a code update or a content testing tool finds an inconsistency between the documentation and the product UI. The docs refer to a button string that doesn't exist. So maybe the docs say, click continue, but it can't find the content validation tool can't find a continue button. So the validation tool sends the error and associated information to the healing tool. The healing tool receives the error and researches the discrepancy by analyzing the documentation, analyzing associated JIRA issues, analyzing system logs, analyzing the Git history. And the tool discovers from the Git history that the button string in the docs was changed the previous week. And it notes what the new string was. Instead of continue, maybe now it's next. Then the tool also discovers from Git and the system logs that a new version of the product was just released yesterday. And that release has the new string in it, which is why the test just started failing. The healing tool can then create a pull request to update the docs with the new button string, change continue to next, and it notifies the writer of any necessary changes and how it arrived at this conclusion. And this can all happen in the writer's off hours. I know it works because I built one and I use them. The specifics of my example might be a bit beyond where some of the tooling exists today, but it is easily going to be there within the next year. And it's built on the same principles that tools like Hyperlint and Promptless and Eckline and Tadata and even GitHub's autonomous coding agent work to traverse doc sets and autonomously suggest edits. I'm using everything I just mentioned today between my work at Skyflow and my work at Doc Detective to trigger self-healing flows and keep docs up to date programmatically. Oh, I was also remiss, docs.dev. But what this lets us do is we can write our code and documentation faster and more accurately. But they're also not without their challenges, because you need to make sure that your agent has access to all of the systems that it needs access to be able to conduct all of the research to actually make an informed response to the issue or code change that it identified. But when you knit these together, content generation, testing, self-healing capabilities, that's where you get a lot of this continuous automated improvement with human guidance. So in a Docs code setup, whether it's from content generation, whether it's from a collaboration platform, whether it's from scheduled testing, it might kick off one of these flows. And whether a human authors the content or it comes from a content self-healing system that's whose changes are approved by content author, then everything else just flows down into the pipeline like everything else does. It enters version control. It goes through your CI/CD pipeline. It gets tested. It gets built and it gets published. This makes sure that we can produce and maintain truly accurate, verified, accurate, and up-to-date documentation throughout the entirety of the development process. And in a CMS setup, the tools might be more tightly integrated into whatever proprietary authoring system you use, but the principles are the same. But these advancements aren't about replacing technical writers. They're about empowering us. They can give us peace of mind, knowing that our content is accurate and up-to-date and trustworthy. And by automating these routine tasks and providing us powerful assistance, they let us focus on the parts of our job that require human creativity, insight, expertise, and oversight. And they allow us to produce better documentation more efficiently and at a scale previously unimaginable. So I see our future as incredibly bright. We're moving toward a world where the routine things are really automated, allowing us to focus on the strategy, the user experience, and real innovation. And our role as technical communicators, as content curators, is becoming ever more crucial and impactful than it ever was before. So thank you for your time. Thank you all for your attention. And I'm very excited about the future that we're building together. Please feel free to connect with me, ask questions here, or on LinkedIn if you want to continue the conversation later on. Thank you.